Welcome back, class. Today we're looking at section 6.1, Understanding Quadratic Functions. So today I am going to show you how to graph a parabola. What's a parabola? A parabola is a U-shaped graph. Y equals ax squared. If a is positive, the parabola will open up. If a is negative, the parabola will open down. If a is a number between -1 to 1, we'll end up with a parabola that's really wide. And I must also mention that a cannot be 0, because if a is 0, then we'll have y equals 0 times x squared, which is just y equals 0, which means that the equation will no longer be a parabola. Now, if a is a number that's less than -1 or bigger than 1, then we'll end up with a narrow parabola. And if a is 1, then we'll end up with a parabola that's of normal size. In addition to what I mentioned earlier, let's look at some key features of a parabola. This point right here, the point that divides the parabola in half, is called the vertex. That's the point in the middle. The imaginary line that cuts the parabola in half into two symmetrical parts, we call that the axis of symmetry. In this picture, the lowest point of the parabola is where the vertex is. Because this point is the lowest point, we call that a minimum. And if we look at the parabola below, we have our highest point, which is also located at the vertex. That highest point is called the maximum. So now let's learn how to graph. Explain 1a. Graph and label each function in the coordinate plane. Compare f of x with g of x. There's more than one way to graph parabolas, but because this is an introduction, let's go ahead and graph these parabolas by making tables. The easiest way to graph it is to make an x and y table. Remember, y is the same thing as saying f of x, so y equals x squared. For my x values, I want to use -2, -1, 0, 1, 2. I'm also going to add a third column that'll represent my point. Let's fill this in. When x equals -2, y will equal -2 squared, which is 4. So my first point is at -2, 4. Go ahead and plot a point on -2, 4. Now let's find our second point. When x equals -1, y will equal -1 squared, and -1 squared is 1. So -1, 1 is my second point. Let's find our third point. When x equals 0, y will equal 0 squared. 0 squared is 0. So the third point is at 0, 0. For my fourth point, I'm plugging in 1. When x equals 1, y will equal 1 squared, which is 1. So that fourth point is at 1, 1. And finally, when x equals 2, y will equal 2 squared, which is 4. So that last point is at 2, 4. And notice how our points are symmetrical, and that's exactly what we want. Here's our parabola. Label it. y equals x squared. Our vertex is at 0, 0. Our vertex also happens to be the minimum. And our lowest y value, which is the minimum, is at 0. And that's how you graph f of x equals x squared. Now let's go ahead and do the same thing, but this time I want to graph g of x equals 2x squared. So I want to keep my graph on here because at the end I want to compare f of x with g of x. Now let's graph g of x. Same exact process. Y equals 2x squared, and then we're also going to add a third column which will represent our points. Let's start off with -2. When x equals -2, y will equal 2 times -2 squared. So that's 2 times -2 squared is +4, and 2 times 4 is 8. Therefore, our first point is at -2, 8. When x equals -1, y will equal 2 times -1 squared. -1 squared is 1. 2 times 1 is 2. So it looks like I'm going to run out of room, so I'll go ahead and just put 2 here, and I'll circle it to remind myself that y is 2. So my second point is at -1, 2. When x equals 0, y will equal 2 times 0 squared. 0 squared is 0, and 2 times 0 is 0. Once again, I'm just going to circle that to remind myself that y equals 0. So our third point is at 0, 0. For our fourth point, x is going to be +1. When x equals 1, y will equal 2 times 1 squared. 1 squared is 1, and 2 times 1 is 2. My fourth point is 1, 2. And finally, to find my fifth point, when x equals 2, y will equal 2 times 2 squared. 2 squared is 4. And 2 times 4 is 8. So that fifth point is at 2, 8. Since I have all 5 points, it's now time for me to graph. So I have a point at -2, 8. I have another point at -1, 2, 0, 0, 1, 2, and 2, 8. Let's draw our curve. Now let's compare f of x to g of x. If you look at the graph, both of the parabolas share the same vertex. They both have a vertex of 0, 0, and both of them have a minimum at y equals 0. If you look at the shape, both parabolas look similar. However, g of x is a lot more narrow than f of x, and that all has to do with a, the number in front of x squared. That number will either make your parabola wide or narrow. Explain 1b. It says graph and label the function in the coordinate plane, compare f of x with g of x, state the domain and range. We graphed f of x equals x squared earlier. I'll go ahead and recreate the table again. If you don't want to do this, then you can go ahead and skip this step and just look at the previous graph. Take those points and plot them. Let's graph g of x, make an x and y table, So notice how this time we have a fraction of 1/2. For my x values, I can continue to use -2, -1, 0, 1, 2, but if I do that, then I'll end up with fractions. To avoid fractions, I'll go ahead and use x values that are multiples of 2. And I went with a multiple of 2 because if you look at the denominator of the fraction, it's a 2. Now, if the denominator was a 3, then I would go with multiples of 3. Let's start with -4. -4 is a multiple of 2. Let's plug that in. Y equals 1/2 times -4 squared. That's 1/2 times -4 squared is 16. Half of 16 is 8. When x equals -4, y equals 8. Let's make our third column for our point. Our first point is at -4, 8. Now let's plug in -2. And I'm using -2 because -2 is also a multiple of 2. When x equals -2, y will equal 1/2 times -2 squared. -2 squared is 4. Half of 4 is 2. Our second point is at -2, 2. For our third point, I want to go with 0. When x equals 0, y will equal 1/2 times 0 squared. 0 squared is 0, and half of 0 is 0. So 0, 0. I'm beginning to run out of room, so I guess I can continue my table on the right side. When x equals, once again, I'm just continuing my table because I ran out of room. When x equals 2, remember multiples of 2, y equals 1/2 times 2 squared. That's 1/2. 2 squared is 4, and half of 4 is 2. Put a circle around that. Our next point's at 2, 2. And finally, when x equals 4, y will equal 1/2 times 4 squared. 4 squared is 16, and half of 16 is 8. So 4, 8. Now that we have all 5 points, let's graph. -4, 8. -2, 2. 0, 0. 2, 2. 4, 8. Draw the curve. Highlight the graph. I'm also going to highlight f of x. So if you compare the two graphs, notice how g of x is wider than f of x. And that's because of our a value. So g of x is wider than f of x because a is 1/2. Remember what we talked about earlier? If a is between -1 to 1. So let me pull up that slide. If A is between -1 to 1 and is not 0, then you'll end up with a wide parabola. We'll skip the domain and range for now, and we'll get into that later on.